Welcome. This is my tutorial on version control for distributed working. So in this tutorial, we'll talk about how to use GitHub and more generally, how to use Git and some of the terminology that you'll run into. We'll talk about this in class as we go over quiz one. And then later in the course, when we talk about other things related to GitHub and Git. So we'll be using GitHub, which is a platform for hosting code. And I want to teach you a little bit about how to author things to GitHub and make a contribution to an open source project. We're going to be working from sort of a repository I've made for the project for the course. So you're going to be, there's going to be a lot of leeway in terms of practice and in terms of what you put in there. So we're just going to do some real simple operations, real simple contributions to start with. Now you'll be using a web interface, and I'll show you what that looks like in class. But this is using GitHub from the command line. So if you're interested in using the command line, you can use the command line. If you're familiar with command line interfaces, this is basically what it looks like. You have to download a client through coi.github.com, and you can get started there. There are different commands that you use to do some of the similar things that you do in a graphical user interface by pointing and clicking on things. So this is something you might be interested in. It gives you a higher level of control, so you can do a lot of things with respect to managing repositories and things like that. So I just used the word repository, and so that's the first jargon term of the tutorial. So what is a GitHub repository? So a GitHub repository is a place that you can set up. You have to sign up at github.com. You have to create an account. And if you create an account and you do that successfully, you have www.github.com / and you pick a username. And then if you go to that address, right here I have pulled up my GitHub user account. And so you can see that I have a username, BALICEA, and that's where I host things. So that's my home repository. Now I'm going to be asking you to use that in conjunction with the repository that I have created for the course, and you're going to be do something called forking a repository so that you can work on it in your repository space. You can log into that repository, and you have control over writing privileges. And then I want you to push that back to the course repository. So those are two other jargon terms. So we'll talk about those in a minute. But if you look at a repository, what it does is it stores the account that you have stores repositories. So you can have many repositories in a single account. And a repository is like a sort of a root for a bunch of files. So each repository in this overview, you have 6 here. These little squares are repositories. They have names. And then you have inside of them, you have a number of things, a lot of files like code files, image files. You can have a lot of different things in there. One of the things that we generally have in a repository is a README file. So it's readme.markdown or .md, and we'll talk about Markdown in the next tutorial. You'll have a README file which describes what's in the repository. So it's usually good practice that everything you have in the repository is described in a README file. Sometimes you can put in a description of some type that doesn't relate to every single file, but it should tell you something about what's there and why you want to, if someone comes, because this is all publicly online, if someone comes to your repository, they can explore the repository. I mean, you can make the repositories private, but let's assume that you have your public repository. You'll want to be able to describe it to people. They also have subdirectories. So a repository will have a top level, which is where all of the things are managed through this root. So it's like a root directory on a computer. You can delete them. You can make them private. You can do different things at the repository level. But within the repository, you have subdirectories. So if you use the graphical user interface for GitHub, you'll see that there are these folders. They look like folders. And you can open them up. And you can create them as well. Those are subdirectories. And so the address for something would be at the top level would be the repository. And then you can give it a subdirectory name, a backslash, and then maybe like a file name. So you could have, for this example, and it's hard to see, the one that it's pointing to is the microscopy uh, repository. And then under microscopy, you may have something like a microscopy one or images or something. That's a subdirectory. And then under images, you might have a readme.md file. So there's a subdirectory images that may store a bunch of images, and then a README to tell you what the order of the images are and what they are. So that's how you store data in GitHub. And a lot of, we won't necessarily go through that part of it, managing the contents of a repository, but it's important to know kind of how things are structured and what to find there. You can also have additional tools. You can have pieces of code. You can have other documents in Markdown or in some other language. There are a lot of things that people host in GitHub repositories. We're not really going to cover that in the course. I don't want to have this become a course on GitHub, but just to suffice it to say that you can do a lot of things with it, and you can find out more on other tutorials and other activities online. So you can go look that up. And then so this, sometimes these repositories function as a project showcase, or sometimes it functions as a server for work in progress. So we've talked about working open, and we've talked about how you want to share your project with the rest of the world. And sometimes you want to make that very attractive to people, make sure that they know what's going on and maybe what can be done to improve upon it or to contribute to it. So, I think some people host their personal websites, their portfolios, their professional work on GitHub through something called github.io. And that allows you to look it up according to their their username .github.io, and it renders as a web browser. But underneath that, if you go to their GitHub repository through github.com, you can see the files. You can see it's a repository that's a github.io repository. And then within that are all the contents of their web page. So you can but you can also use the project showcase through a GitHub repository. You can have, images of whatever the project is. You can have an issue board, which we'll talk about later in the course. You can have a lot of things there that will help people understand your project. So now let's review some concepts. I don't want to get too much into this. In the course lecture, I'll talk a little bit about Git and forking and things like that, and sort of the philosophy behind forking. But I just want to go through some basic concepts of how to do things in GitHub. So once you have your GitHub account set up, once you have a repository forked, so you're going to fork the repository from the course repository. There's a button that says forked, you'll fork it and it'll be there. And that's your personal copy. So you can make changes to that and it won't affect the course repository until you push changes to the repository. And that's a very important property of GitHub. It's this thing called version control. So version control allows you to do make these kind of changes, and be able to have someone maybe review them upstream. So like someone supervising the project might be able to review them, and if there are errors, then they can be resolved. You can also have multiple people working on a project at one time, and you can incorporate their changes without overwriting each other, which is very attractive for group projects, for collaborations, as we've mentioned, and so forth. So the first concept I want to talk about is edit history. So this has to do with version control and how it works. So this is edit history is a complete set of contributions in prior versions. And so we can even back up further, and I'll have this slide in the course lecture, but what is version control? And so in the course lecture, we'll talk about this a little bit, but basically this is the idea of your branch and your sort of your trunk of your main repository. So you can think of this destination branch as the repository, the course repository, in the link that I will give to the course. So you'll have that link. You'll go there. There will be a repository on another organization, an organizational account. You'll fork that, which is a branch. That branch will be then on your GitHub account, and then you'll be able to change that as you wish. But it doesn't necessarily reflect. It gets reflected in the destination branch. The destination branch is unchanged. You can make commits, so you can open up a file and you can write to it, and you have to commit it. You have to say, I want to make a commit, and it will record these commits as a series of events. It'll have a record of these events, and you can go back to earlier events. If you make a mistake and you commit it, you can go back to an earlier event. So all these things are reviewable at multiple levels. In your own repository, you can review things. You can make commits. You can go back to previous versions. You can combine versions and so forth. Once you know what you're doing, it's pretty easy to do some of these things. Then you want to make a pull request when you're done. So in the first assignment, one of the things you're going to do is put your name in a collective name file. So there's going to be a name file on the destination branch. You're then going to fork that. You're going to write your name in the file, name file.md. You're going to make a commit, including your name in there. And then you're going to issue a pull request back to the destination branch, which is going to allow me to review your change and incorporate it into the destination branch. So what will happen is you'll have this namefile.md, and at the beginning I'll just have my name in there. And then you will have, each person will fork this file, this repository. You have to fork the entire repository. The one file, you'll make the change, and then you'll push it back to me so I can review it. And it will include your name. So when I do this for everyone, it will have everyone's name in it. And so this is the way everyone's kind of contributing to this document. And I want to demonstrate how this works so that, you don't overwrite people. You can have like multiple versions of it. And the comparisons between versions are done automatically. It's all automated. And so you don't have to worry about doing things as a reviewer or as a contributor. So that being said, there can be some work that happens inadvertently. In some of the prior course experiences, there's been some on the reviewers end mainly. There's been some difficulty with some of the files, but it's easy to sort out once in this kind of system because you know that you have records of everything. So there may be some manual management that needs to happen, but this is a good way. And I think this walking through this process will give you an appreciation for how this can benefit the project manager. So we have a couple things to talk about here. Once you get into your repository and you get into a single Markdown file, you'll see that there are a number of things in the interface. So this is the graphical user interface for a sample repository, a sample subdirectory, and then a sample file. And so this is a Markdown file. And this Markdown file has a bunch of content. We'll talk about Markdown in the next tutorial. But what you see here is you have a couple of buttons up above the text, raw, blame, history, something that looks like a pencil, something that looks like a garbage can. If I want to look at the code, I can click on raw, and it will show me what the code looks like that's rendered this text. So when we'll talk about this in the Markdown tutorial, this will have like some formatting, and that's not important to actually viewing the file, but it is important to making sure the file looks like this. So there's some formatting in there that you can see if you press raw. Now, if you press history, it allows you to view the commit history. So what that means is that this file is the product of many commits. Sometimes, there's a single commit to put the code in. You can put it into a window using the graphical user interface, or you can use, there are other stylistic changes or maybe wholesale changes you might make to the content. and you keep committing this. And so what you can do is view a history of those commits. Now, say you have this file, edit it, and you make a change and you notice that you've deleted something from the file accidentally. So you don't want that. You want to restore the thing you deleted. So what you can do is you can click on the history and it goes back to a number of different versions, each version being some point in time in the past. Then you can go back to that file, open it up. You can click on raw. You find the code and the text where you deleted. You grab that, you copy that, you go back to the original file. You can paste it into the edit function and then commit, and you've restored that content. So very easy to deal with, like historical revisions and going back in time and bringing things forward, because it saves a copy of everything, and it allows you to compare things as well, which is not something you can do with the history function, but there is what they call a diffs function, which we'll talk about, that allows you to compare text character by character and line by line. The pencil, a couple icons down, is the edit button. So you click on that to edit the file. That allows you to edit it in this interface. You can then add your changes, make changes, do whatever you need. And then when you click on that, it brings up a different dialog and it shows you sort of a window with the raw code, which is editable as opposed to like just clicking on raw. And there's a button below. If you go down to the bottom, there's a green button that says commit. And it's very important to hit commit, because if you don't, you lose your work. So it's not automatically saved. It's just kind of a thing that you have to commit to the repository. And there's a very good reason for that. You want to make this is just a system to ensure that you actually commit what you want to commit. Sometimes people will make changes and then don't want to really do anything with the file, or they take a look at it in the editor and they say, I don't need to do anything with this. There are different reasons why you may not want to commit something, but you have to commit it to make the change. Then the garbage can is, of course, to delete the file. Sometimes people will delete files if they're no longer necessary. If you're maintaining a repository, you may not need the file anymore. You throw it in the garbage. And so this is an example of the history. This is where we have our files. You can see that they have their own identity. Each commit has its own identity. It has a date. So these things, and by contributor. So you can see if one contributor versus another contributor made a change, where those all are. So it's a very good system for tracking contributions and changes and comparing them and making sure that nothing gets lost, that everything is the way it should be. And it's very useful for writing documentation, but also even things like writing books or writing papers in a system like this. So they're very useful in a number of ways. So this is, again, the history. This identification number here just tells you that there's you can view the document changes for this particular commit. And you may not remember the identification number, but that's not important. What's important is you look at the left-hand side, you look at the contributor and the date, and you can kind of get a sense of maybe when that change was still in the document, or where you can find it. So you can open it up, you click on that button, and you can restore things. So now let's talk about branching and merging. We've talked about a little bit about GitHub and edit histories, and a little bit about pull requests and how to do some of these things. Now let's talk more deeply about branching and merging. So there's a lot of jargon here that people use. There's, they'll throw it around and it'll be hard to follow at first. You'll kind of learn what people mean. So this is a graphic that kind of describes some of this. So branching something, when we talk about those branches, those are forks. We talk about it as forking because you're forking. It's like forking a path or forking a river. It splits into two. It ramifies. And so that's what we mean by fork. The fork then is, those are two independent things, and they get merged back together through a pull request. So a pull request is basically merging Sometimes people will say that if you take from your own personal repository and you issue a pull request to the home repository or the organizational repository, that's a push. You're actively pushing it to there. But they use the term pull request because you're requesting that your work be pulled into the main repository. So it's basically a difference of perspective. The pull request is a request, something to be pulled, and it's either accepted or denied, or you have to make changes to it. And actually issuing the pull request is a push. So you're pushing it out to another place. Now, people will use what I'm describing to you is this sort of trunk development where you have things on a trunk, you have forks or branches off to different repositories, and that you can, that it's largely to different trunks. So you have a trunk as a personal repository. The organizational repository is a trunk. You're moving things from trunk to trunk. It's like moving between two different trees. Then there's branch development. So sometimes people will use branches, like we use forks. In this case, we're going to use forks because you have a repository and we have an organizational repository. It's just easier. But sometimes people create a lot of branches. And so you'll create a branch within your repository and you'll name it something. So a lot of times in software development, they'll use this. They'll have dev versus production versus test. And, those would be different branches you can move to. So you move content in the repository from the test to the dev to the production. And it keeps things, separate in terms of their readiness. So you don't put stuff that doesn't work in a production model or in a development model even. So these are different strategies, and you'll learn about them as you read more about GitHub, but we'll talk about them in class. This is a good graphic to kind of familiarize yourself with some of these ideas. So you'll be creating a branch. Using that branch, you can safely experiment and make changes. So you can change once you have a fork or a branch of your of the repository. It'll be under your account, so you'll see your alias / the name of the repository, as opposed to the name of the organization / the name of the repository. You'll know it's a different place, and so you'll be able to create this. You can test out things. You can play with the file, and none of that will have an effect on the main repository. You can add commits. Then you open a pull request. So then, once in this case, it's a very simple thing I'm asking you to do, put your name in the file, but sometimes it'll be more detailed. So if you're doing a lot of coding, you might do some experiments with code. You might see if it works, see if it doesn't work, and then you'll actually commit the thing that works, or you'll have to make commits to get it to run, or you'll have to make commits to, have like candidates to choose from. But all these things you can do this without affecting the main repository. But when you're ready to go, when you have everything set up, then you can open a pull request. And we'll talk about some of the details of this later in the course. But basically, you'll be opening a pull request to the main repository. You'll fill the form out. It'll be like there will be changes that you'll have. So it'll enumerate the changes, the changed files, and some description of what they are. So a word about issuing like commits and pull requests is there's always a window for a description, and try to make a description if possible. It could just be like added my name or changed a font or something like that. Even if it's very simple, you click on commit and it'll show up in the pull request as the file and then the description. So it makes it easier on the maintainer to know what it is or the person reviewing the pull request, what it is you want to make the change to. And so then all of that will be done, and then you'll have a description in the pull request window that says, what do you want to do? So in a lot of organizations and a lot of open source organizations, people will link to specific issues, and we won't do that here, but we'll talk about that about issues later. Or they'll kind of get into a discussion with the person accepting the pull request on how to do X, or this is a good solution to X because Y, or whatever. And so this allows you to do this. And of course, the pull request is great because it allows you to do this anywhere in the world. I can send this pull request to anyone anywhere in the world, and it's basically in the same system. So they get it in their time zone, or if they're working at a different time, they can review it at their leisure and then accept it or send back a request for changes or reject it. And so sometimes that happens. You can do all those things, but it makes managing things easier. Then you can have a discussion and a review of the discussion. So you might say, I have a good solution for project problem X because of Y, the changes I made here. And then the person might say, well, there's an easier way to do this, or you're missing some steps, or something like that. And so then you can go back and make those changes. And you can go through rounds of review. And then finally, once you're done with that, you can merge and deploy. So then if the pull request is accepted, or once it's accepted, then you can merge those changes and it's deployed on the home, on the organizational repository. And everything is, incorporated into a larger scheme. So when we have the name file, hopefully at the end of the assignment, when everyone has made their contributions, we should have something like 10 or 11 names in there. And so we can look at that in class and see our collective contributions. The other thing I want to talk about is forking. So this is sort of the first step, and I put it last, but that's okay because it's pretty easy. There's a fork button at the top of the screen, right-hand side of the GUI. You're going to go to the organizational repository, signed in under your account, and you're going to hit fork. And when you hit fork, it's going to make this fork. It's going to have this little graphic, so you know it's forking. The fork will go back and forth over the book being copied on a copier. It's the idea here is that you're making a copy of this repository at the current state, but in a system sense, you're forking it, so you're moving it to your own repository. So you're making a copy, moving it to a repository, and then that copy may or may not doesn't update automatically. So you have to actually update it. And we'll talk about that in the next quiz. But you can update these forks. So when I fork a repository, it takes the repository at the current state. It's that content at that time. And then sometimes you may sit there for like a month and you might not make any changes. Boy, did the organization ever make some changes to it. So then that's when you want a refresher fork. And we'll talk about that in the next homework. But basically, it's an icon in the GUI that allows you to refresh your fork to make, to compare changes and to update everything so that you have a new version. If you fork this repository, like at the beginning of these, I give you a week to do the assignment. If you fork it right when I issue the assignment and you don't get around to doing it until the end of the period that the assignment is due, then you may have to refresh your fork. And you just look, it should be down where it says on this graphic, clone or download in that area. So look for that refresh your fork. And then it'll just like tell you what kind of changes or differences exist between the two repositories. And you say refresh, and it'll refresh everything and give you sort of a copy of it at that time. So this is how forking works. And this is how we get this ability to sort of break things off, make a copy, play with that copy, make changes that we can then sort of assign back to the dominant fork, or the fork of the organization that we're interested in. And so this is, again, an example of this. Once the fork is made, if you notice in this instance, the organization is DevoWorm. And then in this case, the account name is BALICEA. So that's my personal account that I've forked from DevoWorm. And so you can see that it says forked from underneath. So it's just a way to know that you forked it and what version you're working in. So you want to work in the one that's on your own personal account because that's where you have full permissions and that's where you won't interfere with anyone else's work. And so then you go, when you want to issue a pull request, you go to the pull request tab, which is up at the top of the, you'll see up here that you pull request tab. It's next to the code tab, which is the main tab where you can view the contents of a repository. Then you'll hit the new pull request button, which is right there in the green. And then that will create a pull request, and it'll basically take everything in that repository that's different. Say this is what's being contributed to the main repository, the organizational repository, and then describe what your changes are and issue a pull request. And if there are some conflicts, which happens, you may end up, before you issue the pull request, go back and refresh your fork. Or, if there are conflicts, and there shouldn't be conflicts in these assignments, the conflicts should be minimal. But sometimes in real life practice, you'll have conflicts that need to be resolved. And so those are going to be you're going to figure out what those are. It's going to be very difficult to do sometimes, but that's the way that this works sometimes. Most of the time it's pretty seamless. So once you do this, then you issue your pull request. And then in the organizational repository, when I look at it, it'll say pull request 1 or pull request, how many of our pull requests have been issued. Because multiple people will probably be issuing them around the same time. I'll have a stack of pull requests to review. And so then I'll review them, accept them, or reject them accordingly. And that'll be the assignment. Now you can do everything I mentioned in the command line interface, but the commands, you have to learn the commands for all those things. So all of that can be done through the command line interface. I would not recommend that for this assignment unless you're very comfortable with that, because it is, you do have to call everything from the right directory. And there's also a way to have an interface on your desktop so you can work with the files locally and then push them back up into the cloud. So that's another option too. Then that's GUI driven. So then this is actually where we can compare changes. So I can, as a reviewer of this pull request, or sometimes as the person who's issuing the pull request, I can actually do something called diffs, where I can look at diffs and I can see where the changes are. So in this case, I'm creating a pull request on this file readme. I'm updating readme, and I'm adding in some text. And the text is sometimes it's crossed out with a strike through, or it's in a different color font. And so you can actually look here at the red block versus the green block. The green block at the bottom has no changes. It's consistent with the two repositories are consistent. The red block is a difference between the two repositories, and they're highlighted. So you can actually look at these diffs line by line or character by character if necessary to understand what the changes are. And especially if you're reviewing it or if you have conflicts, that will help you. It will help you look at the different changes and what they look like. So that's useful. You don't have to do that every time, but it is useful if you have a conflict or if you just are curious as to what it's going to look like when it's committed. So this is opening a pull request. This is where we have this comparing changes step, and then you're actually opening the pull request. And sometimes the comparing changes will pop up, before you actually open this pull request. But basically, you want to do two things in a pull request. You want to give it a title. So right here, the title is update readme.md. Make sure that is filled out. If it's not filled out, you can't issue the pull request. The green button is grayed out. You need to add a title. It should just be very descriptive. And then leaving a comment. You want to leave a comment, even if it's just like added my name to name file, because it's just good practice. That's good to get into that habit. The other thing I want to understand is this box right under open a pull request. You have a base repository and a head repository. So your base repository is going to be the thing that you're pushing to, and the head repository is the place where that change is coming from. So your head repository should always be your personal repository. The base should always be the organizational repository, at least in our assignments. You'll see base and, the base and comparance as master. I talked about the branch strategy of development before. Sometimes you'll use branches. So sometimes it'll be like the base and the head repositories will be the same, but it'll be a different branch. And so you may want to change base and compare there. But don't worry about that for this assignment. And you'll, when you get more comfortable with GitHub, you can do that to your heart's content. And then below that, it says able to merge. So the way you know that you're ready to go is it says able to merge. And usually it'll just populate this automatically. You don't have to worry about futzing with this. It's just a thing that that I wanted to bring your attention to. Give it a title, give it a description, create pull request, and you're done. And then it's submitted to the organizational repository. And so this is what a pull request looks like to an administrator. So I'm the administrator of the master repository. I'm going to get this. It's going to give me a pull request. Notice that there's a 1 next to pull request. And I'm going to open that up, and that's what it looks like to me. It'll say that continuous integration has not been set up. Continuous integration is, and we'll talk about this, I think, later in this tutorial, is where you have things are, if you're working on a software project and you need to know if it's going to run, then continuous integration is for you. But you don't need to set it up if on a repository if it's not necessary. And then it says this branch has no conflicts with the base branch, merge pull request. So I can just merge this and it's done. And so then that's what it looks like when it's done. It's been merged successfully. Now let's talk about task issue and management. So the final area I want to talk about is task issue and management. This is going to be relevant to your second quiz. I want to talk about it now because it kind of flows from the GitHub, the basic GitHub tutorial, and then you'll maybe want to refer back to this for quiz 2 if necessary, because you will be creating your own tasks on a task board. So if you look at what a issue is in GitHub, it's a list of sort of like tasks. They're given numbers, so they're given a unique number, and you're going to have a list of them that you can look at through this Issues tab. So you see that there's this Issues tab. It's next to code. In this case, it's between code and pull requests, but it says issues, and you're going to have this list of issues that you can review. So if I want to review these issues, I want to look at what's been done or how many issues we have. I can just take a look at this list. It just comes up right off when you hit the Issues tab. And each issue has sort of its unique ID number, so you can identify it. You can actually put it into any comment you want, and it'll automatically link to that issue. So number 23, you just hit #23, and it'll create a link to that issue. The issue also has like a description within it. It has a title, just like a sort of a pull request, but it describes something that you may want to bring up. It could be a new feature in your project. It could be a thing to do. It could be like a larger scale thing that you want to, accomplish in the future, but you don't really know what size you want. We'll talk about those things later. But basically, you have a unique number, and then you want to tag each issue with a status, ideally. So some of these are tagged by help wanted, maybe good to have, or linked to something else, or maybe good first issue, which is something you might give someone who is just starting out in your organization. Those are all things that you can do that are, you just let people know what they're there for, what category they belong to. So there are a lot of ways you can classify these issues, but suffice it to say, you can create new issues, you can review issues, you can close issues, and you can edit issues as need be. Issues can also be updated with comments. So this is going into a single issue. This is segmenting bright field images number 11. This is just a task. So this is something that's pretty straightforward. You can leave a comment. You can maybe make a description. I didn't make a description because it's pretty basic. But if one were to make a description, you could. and then you might assign it to someone, and then you might actually leave a comment and say, I want to take this on, or I'm having a problem with this part of the assignment or this part of the issue. I'm going to create a new issue that sort of breaks this down into separate issues, that sort of thing. And so you can do this. You can assign it to specific users. You can, um, add it to a project. You can add labels, which we'll talk about in quiz 2, and all these things. And it gives you this sort of flexibility to, this is always on a, this is always in the issues of the organizational repository. So we don't necessarily want to host these in our personal repository, because then the rest of the people in the organization can't see them. So in our class, if we have a class issue board, and I want to, have issues for different people in the class, I want to do that on the organizational GitHub. I don't want to do that on the personal GitHub, just because the other people won't have access to them. So it's important, and you can't pull request these to the main board. So it's important to create them on the organizational board or on the organizational GitHub account, and to create issues that are, both compelling and easy to fulfill. And so we'll talk about that later. In any case, this is what an issue is like. And so an issue board is just a way to organize these issues. As you saw on the first slide of this section, I have a list of issues. And if I have 200 of those, it's pretty unwieldy. I have to scroll through, and I don't know what the statuses are. I can't really view them in context because they're all over the place. I have the tags, I have the assignees, but I don't necessarily know how they relate. So this is a project board. This is based on a Kanban board, which you'll learn about. This just shows like issues in various categories. So this shows them in various states of completion, to do, in progress, and done. And you can see that they have assignees, they have tags, they have their number, they have their description. You can click through to the actual issue. But what the advantage of this is maybe 2 or 3-fold. So the first advantage is that you can look at them in context. You can see how many tasks do we have to do? What are they? We have a set of tasks in progress. What are they? And then, maybe we can think, maybe we need another category. Maybe we need to have like a hold category. Or maybe we can actually update our issues in terms of where they belong in the workflow. So a to-do issue might have been started. So we can move it from to-do to progress. So that's the second advantage, is that you have this ability to move them from category to category, to view the categories, to make new categories, and so on. The third thing is it allows you to sit in a meeting and actually review these with people. So you can share this information with people in a way that people can understand the larger context. So say I just say like to you, I want to move number 36, issue number 36 from to do to in progress. I can tell you that in a text message on a message board, or I can tell you that in a meeting, but it doesn't really, it doesn't really connect with me in terms of project management flow until I show you on a board like this, to show you that's moving over, and then to see what's in progress. Maybe you have too many things in progress, and we maybe need to put some things on hold that we wouldn't otherwise put on hold because we just have too many things in progress. So these are all things that we can do with project boards. They're very versatile, and we'll do some more work with this in quiz 2. And so this is where we can move cards to their status. It's very easy to do. It's also easy to sort of see where you maybe make sub issues of a certain issue, or maybe make new issues that we haven't thought of yet. I also want to talk about cloning a software repository. So that was about issues. This is more about some of the things you can do with GitHub outside of the basic paradigm. So one of the things we like to do with GitHub repositories is clone them. If you want to, say, contribute to a software project, it's largely code. You don't really want to contribute to it so much. Maybe you want to run the software inside of it, or you want to create it. Well, you can create a release, but that's a different process. But you want to basically take it, download the software, and run it on your machine. You don't necessarily want to actually modify the code and push it to the organization. So that's what we do when we clone software. So cloning it is just taking a copy of it, but instead of forking it to your own repository, you're just downloading it to your local machine, and it has the file structure exactly the way it is in the software repository. So it has your subdirectories, your files, everything is in the same place. And this is important when you run software, because if you have an executable in there, you compile the software, everything needs to be in the right place. You're cloning from a certain location on the web, and then it says open in GitHub desktop or download zip. Usually people download a zip. Sometimes you can clone a repository to your GitHub desktop if you want to work on it in the desktop app, or if you're interested in inspecting the files that way. I mean, there are just different ways to do this. But cloning is something you can do that you may not do that ever, but it's it's a valuable thing to know how to do.